Hello all. Today let us analyze the truss element using an ANSYS Workbench. Determine the deformation and stress in each member when area is equal to 0.05 meter square and Young's modulus is equals to 210 gigapascal. Okay. Here in this figure, we can see that we have three number of nodes, node number 1, 2 as well as 3. First node is fixed and third node is fixed. And at the second node, we are applying a load of 10 kilonewton in positive y direction. Okay. So it is a positive y direction. Now let us analyze this using an ANSYS Workbench. First, static structural, track this engineering data. In your engineering data, we can see that here we don't have any different material. The two materials are same, so that we can consider the structural steel only. By default, it will be a structural steel and check the Young's modulus. Here the Young's modulus is same, that is 211 in Pascal. So no need of changing this one. And let's move on to the second step. Project. Here geometry, new design modular geometry. Here, same. I will do this in meters only. We can do in meters or millimeters, anything, but I will do in this in meters only. Now, XY plane, right click, look at. So you can see that we have a XY plane here. We have a XY plane. Now, you can see the figure here. We have a two elements here. This is one element and this is one element. Okay. Now, I'll draw this one. Now, I'll zoom this one. Go to the zoom. Okay. Now, I'll draw sketching line from this center. I'll draw a line, and again from here I'll draw the line. Okay, after this we should give a dimensions. Okay, dimensions. We have here the horizontal and vertical. Here we have a horizontal 2 meter and a vertical we have 1.5 meter. Now what I'll do here is, first I'll give the horizontal. Select the first node and this give the horizontal one. Horizontal I'm doing in meters, so it is 2 meters. So I'll give as 2 here. Okay. Now I'll give the vertical direction. Go to the vertical. Same. Select this as well as this and give the vertical direction. Vertical direction is, we have the figure, we can see vertical direction 1.5. So I'll give this as 1.5. So now you can see that here we have created the sketch. Okay, now fit this. Fit. Zoom so that okay, we have zoomed. Now you can see that we have created the model same as this. Okay, after this we have to do the line from sketches, similar steps as the bar element. Concept, go to the concept, line from sketches, select first and again control second element, then give apply and then generate. This completes the second step. Now we can see that the line is created as well as one part is created, one part and one body here. Now what we should do, we should give an area. Okay, so in order to calculate an radius, now we have area is given. The area is 0.05 and area of the square circular cross section is A is equal to pi r square. Area is equal to 0.05 and it is pi r square. Now I want the value of r, so that r square, here with the cross multiplication 0.05 divided by pi, and r is equal to square root of this answer. We'll get it as 0.126 meter. So we will get the radius by calculating in this way. Okay, now what I'll do here is, I'll go to the concept, cross section, circular. In a circular I should give a radius. What is the radius value we got? Radius is 0.126. Okay, after this, now here one part one body is created. Now go to the line. In a line you have to select the circular one, then give generate. Okay, so you can see that one part one body is created and here one cross section is given, and this completes the step number 2. This completes the step number 2. Okay, generate. I'll close this one. Next is modeling. Go to the modeling, edit. Okay, here geometry already one part is created here. Okay, so line body here. Go to the mesh. Before this, here we have a different view. Change it to the front view. So that I'll go to the display. In display, you have views. Select front view so that you can see the figure. Whatever the figure you have created here, same as that of the question. Okay. Now I want to do the meshing for this one. Next here is go to the mesh. Right click. Generate mesh. Generate mesh. Now you can see that mesh is created. Okay, mesh is created. After this, we know that we have to apply the boundary conditions. So here in the figure, we can see that first and third node is fixed. So now what I'll do here is, now I'll go to the static structure, same procedure, static structural. The static structural, we can see that we have environment. In the environment, or otherwise you can also right click, insert, and you can also give here also the boundary conditions. But I'll take here fixed, so that fixed, it is fixed on the vertex. So I'll select here vertex, select the vertex, now give apply. Now this has been completed. Similarly, the third node is also fixed. So again, fixed, fix, select the vertex, again give apply. So that we can see that here is one fixed support and here is one fixed support. Now I have to apply the load in the second node load. And similarly, now you go to the loads. Here force is there, force, and in the force, as I told, whenever you are applying the force, you have to give the components. You should change it to components, change it to components, and it is asking whether x, y, z component you should apply load. Here you can see that you are applying in the positive y direction. Okay, you are applying in positive y direction. So now what I will do, positive y direction of what is the force is 10 kilonewton, means 10,000. So now I substitute is plus 10,000. 10,000. Okay, now I will select the vertex, which vertex I am applying the load. Now give apply, so that you can see that positive y direction we are applying the load. Now you can check all the boundary conditions. Now you can see node number 1 is fixed and node number 3 is fixed, and node number 2 we are applying a load of 10,000 in the positive y direction. Now go to solve command solution. Now go to solve this is solve command. After this, we have to determine the different values. So now I'll go to the solution, insert. In a insert, I'll determine the deformation directional. We have to determine the deformation in both x and y direction. Here you can see that directional deformation x-axis is already is there. And again go to the solution, insert, deformation directional. Change it to y-axis here. Change it to y-axis. After this, I should also determine the value of stress. Again solution, insert, beam tool, solution, insert, beam tool. Here you can see that in a beam tool you have direct stress, minimum combined stress, and maximum combined stress. Now I'll go to solution, evaluate all results. Now you can see that this is a directional deformation. We have a maximum 3.9 into 10 to the power of minus 5. Maximum is minimum is 0 minus 0.00 in deformation x direction. This is in y direction. Direct stress, the stress value, the maximum stress is 3.34 into 10 to the power of 7, and minimum is 2 minus 2.6747 into 10 to the power of minus 7. This is a minimum stress and maximum stress. If you want to do in the 3D view, we have to see this one. Go to the display and give display. Now now you want to see the Excel sheet results, worksheet summary. Here you can see direct deformation, direct stress,